Welcome back to the study of differential calculus. In our last video, we did some few differentiation. In this video, we're going to talk about chain rule. But before I start up, please, I need you to like this video, subscribe to our YouTube channel, and share this video to help us to help you. So before I talk about chain rule, I quickly want to just talk about different ways you can see your differentiation so you don't get confused when you see them outside. Now, other than saying dy over dx, there are several ways this is written. It can be written as y prime. It can also be written as the f prime of x, meaning the differentiation of a certain function of x. And it can also be written as y subscript x, or it can be written as y dot. Now, whenever you see it as y dot, it is always with respect to time. Every other thing can be with respect to x, but whenever there is a dot here, it is always with respect to time. So this is basically more used in physics, while every other thing here are used in mathematics. So you use this. Commonly, these three are the most commonest. So chain rule. Now, when you hear chain, what comes to your mind? When you hear chain, what comes to your mind? What does chain do? That's the first thing you should ask. Or why is it called chain rule? What is it all about? Now, a chain actually, let me call a chain a rope. What a rope does is like it holds something, or sometimes it connects something to another. Let's say I have this marker and I want this marker to be suspended here. I can use a chain or a rope to connect it upward and connect it to somewhere that will hold this. So actually the rope is more like connecting this to the top. That's what chain rule is all about. Let's say we have a function y equals to 2x plus 3 raised to power 5. And you are asked to differentiate this. This is where the problem first of all comes into place. In doing this, you can first of all open this bracket into several, so that your function will be very long. Then you start differentiating each term one by one. But in doing so, you are already wasting much of your time. You are wasting much of your time. So this is where the chain rule comes. The chain rule is more like coming up with a variable that will connect you to y and also connect you to this power. So the chain rule is coming up with a function that will connect you to y and will also connect you to this power. And this function is what actually connects you to y and this power. Now that's where the chain rule comes into place. So this whole function, we'll call it another variable, u. Let's say this function is u equals 3x plus 3. So this u connects us to this and this. Our y becomes, because we have changed this to u, I will write it as u raised to power 5. So let's first of all differentiate these two things separately. Now, when I'm differentiating this with respect to x, my du over dx, here my du over dx will be the differentiation of this plus the differentiation of this. Now, when I differentiate this, the power of x here is 1, so we have 2 times 1, which is 2. Then x raised to power 1 minus 1, which is 0. So basically, this is just 2. We said that in our last video. Then plus the differentiation of a constant. When we differentiate a constant, it gives us 0. So we have gotten this part. Then we'll also come here and find our dy over du. Since there's no x here, now instead of us to be looking for dy over dx, we'll be looking for dy over du. Now, what did we say if we have this? What do? The power will come down first. 5 times 1 is 5. Then you subtract 1 from 5, which is 4. So you have u raised to power 4. Now, but that's not actually what we are looking for. We are not looking for dy over du in the original question. We are not looking for du over dx in the original question. What we are looking for is dy over dx. So how do we manipulate these two things to get our dy over dx? Now look closely. This du is at the denominator, and this du is at the numerator. So if I multiply these two things together, this du can cancel out with this. So if I have dy over du times du over dx, so our dy over du is 5u raised to power 4 Then our du over dx is 2. So we have multiplied 2 of them. Now this du can cancel up this one. So we are left with dy over dx. So our dy over dx becomes 5 times 2, which is 10. 10 u raised to power 4. Remember that in the question, nobody asked you to find u. You were the one that put this u here. So you have to remove this u as much as you can. You have to remove this u, because whenever your answer is like this, you have failed it, because nobody asked. There's no u in the actual question. So this part that we have u, remember we said u is 2x plus 3. So anywhere I see u, I'll change it to 2x plus 3. So I'm going to have 10 brackets 2x plus 3 raised to power 4. So this becomes the gradient of this curve. Very straightforward, isn't it? Very straightforward. Now, anytime you have a function raised to power something, that's where the chain rule comes into place. This power could be negative, this power could be positive, this power could be an irrational number, as the case may be. Now, a shortcut in doing this, how do you do this very fast rather than writing all these long steps? Now, if y is something like this, what you do is that you follow the normal procedure. 5 will come down, the power will come down, which is 5. Then minus 1 from the power. The power is down, so when you minus 1 from the power, you're going to have 4. Then you differentiate this one inside. When you differentiate whatever is inside, you're going to have 2. 2 times that power is your 10. That's why we have 10 here. Then don't forget, you minus 1 from the power. That's why we have this. So let me go with another example. If you have y equals to 4x squared plus 1 raised to power 5. Let me use this as an example. Or let me say there's also an x here. And you are asked to look for dy over dx. The first thing to do is to differentiate whatever is inside. When you differentiate whatever is inside, you are going to have 8x plus 1. When you differentiate this, you are going to have 8x plus 1. Then multiply it with this power. Then subtract 1 from the power. So this will be your answer when you find your dy over dx, which can be written as y prime. So that's the shortcut of doing that. So I can as well write it as y prime equals 5 brackets 8x plus 1, then bracket 4x squared plus x raised to power 4. Now, if for example you are not writing an OBJ exam, you are writing a theory exam, you have to show them how you got this answer so fast. So we have to follow this procedure by making this function here u. So I can change it, let u equals 4x squared plus x. Our du over dx becomes 8x plus 1. Now, since we said u must be this, our y will become u raised to power 5, such that dy over du will be, when I take 5 down, I'm going to have 5 u raised to power 4. Now, remember we said in chain rule, you have to multiply these two things. This is actually the chain rule here, that dy over dx is dy over du times du over dx. So we are going to have this times this. So when I multiply this times this du will automatically cancel out. So we are going to have dy over dx equals to 5 times this. So we have 5 times 8x plus 1. Then u raised to power 4. Remember we said that u is 4x squared plus x. So we are going to have 4x squared plus x. Then raised to power 4. Can't you see we had the same answer? So it's faster when you jump all these steps and go straight to the point. Let's do more examples. Now suppose we have y equals 1 over x 3x squared plus 4x plus 1 raised to power 3. Let's say we have a function of this nature. How do we find the y over dx? Now this function is the barrier here. So first of all, the first thing is to take this function up. So I can as well write this as 3x squared plus 4x plus 1. Then because I have brought it up, this power becomes a negative power. That's from our rule of indices. Now this is where the chain rule will now come into place. In our chain rule, we always let this particular function to be to be u. So this is the part that will become the u. But instead of going through that long process, remember we said first of all differentiate whatever is inside. So our dy over dx will be, first of all differentiate whatever is inside. When I differentiate this, I'm going to have 3 times 2, which is 6. Then minus 1 from the power, we are going to have x. Plus, if I differentiate this, I will have 4. And when I differentiate this constant, I'm going to have 0. Then multiply it with this power, which is minus 3. Then whatever is here, then subtract 1 from the power. So we have 3x squared plus 4x plus 1. Then subtract 1 from the power. So our dy over dx, which can be written as y prime, would be minus 3, open bracket, 6x plus 4. Then open bracket, 3x squared plus 4x plus 1 raised to power minus 4. Minus 3 minus 1 is minus 4. So if I don't want to write it in this form, because there's a negative power here, I can bring this negative power downward so that I will have this 3x squared plus 4x plus 1, everything raised to power 4. So I brought it down. So when you have this function, if you differentiate it, you will have this. Mind you, this can be written as this. It's possible that you don't have only 3 here. It's possible that you have 3 over 2. It's possible that you have 7 over 2, as the case may be. Let me give another instance. Let's say you have y equals to the third root of 2x squared plus 1 raised to power 5. Now remember we did an example of this nature in our last video. So our rule of indices, we have to manipulate this thing to our taste. So I can write this as 2x squared plus 1 raised to power 5 over 3. Indices allows me to rewrite this to be in this form. Now since it's already in this form, I can now solve carefully. Remember our chain rule, we are letting this to be u. So we can say let u equals this. So instead of going through that long process, let's just do it quickly. The first thing first, differentiate whatever is inside. You are going to have 4x. Then multiply it with the power 5 over 3. Then subtract 1 from the power. Subtract 1 from the power. So we have gotten our dy over dx. Our y prime becomes 4 times 5 is 20. So we have 20x over 3, open bracket, 2x squared plus 1. Then when I do 5 over 3 minus 1, 5 over 3 minus 1 is the same thing as 5 minus 3 over 3, which is 2 over 3. So this is 2 over 3. You can leave your answer to be in this form, or you can also write it to look like the original question. So this can be written as 20x over 3. Then this 1 over 3 here can be written as cube root. Remember we said that in indices 2x squared plus 1. So that will be your dy dx if y is this. Very straightforward. Now what if you have some special functions other than your normal x and y? What if you have trigonometrical functions, your logarithmic function, and so on? Your chain rule can still come into place. Your chain rule can still come into place. Let's say you have y equals to sine 3x squared plus 1. Remember we said when you differentiate sine, you are going to have cos. So this point, we are going to change this function to be u. So u becomes 3x squared plus 1. Our du over dx becomes 3 times 2 is 6. So we have 6x. We have gotten our du over dx. Since we said u is 3x squared plus 1, anywhere I see 3x squared plus 1, I can change it to u. So instead of writing y equals sine this, I'll write y equals sine u. What will be our dy over du? Remember, when you differentiate sine, in our last class, I dropped a table that if you differentiate sine, you are going to have cos. So when I differentiate sine u, I will have cos u. So what will be our dy over dx? Our dy over dx is actually this times this, which is dy over du times du over dx. Then equals to this times this. So we have this times this, sorry, cos u times this. So we have 6x cos u. So our dy over dx becomes, remember we said u is 3x squared plus 1. Our dy over dx becomes 6x cos 3x squared plus 1. So that will be our answer. Very straightforward. So you can still use the shortcut for it. That whenever you have this, first of all, differentiate what is inside. If you differentiate what is inside, you have 6x. Then multiply it. Remember, when you differentiate sine, you are going to have cos. So change it to cos and repeat the same thing. So it's basically the same procedure. Let's say you have y equals to cos 3x squared plus 4. Remember, the shortcut, first of all, differentiate what is inside your dy over dx. If you differentiate what is inside, you are going to have 6x. Then remember, once you differentiate cos, you have minus sine. So let me put the minus sign. Whatever is inside here, you repeat it. That's just your answer. It's very, very easy and straightforward. So if you have a function, sine of a function, and you're looking for dy over dx, differentiate the function and times it by cos of the function. What if it was exponential? Let's say you have exponential 3x squared plus 4. And you are asked to look for dy over dx. Simple. Your y prime, differentiate this power first. When you differentiate this power, you're going to have 6x. Then exponential. Remember, when you differentiate exponential x, you're going to have exponential. So you repeat the same thing. Very straightforward. I don't know if you are getting the pattern already. What if you have y equals to ln 3x squared plus 4? Remember, when you differentiate ln of a function, you are going to have 1 over the function. But there's a function here. So the first thing, differentiate whatever is inside here. You are going to have 6x. Then all over this function, 3x squared plus 4. But if you do not understand it this way, come back, change this 3x squared plus 4 to be u, and you get it. Change this 3x squared plus 4 to be u, then you differentiate the normal u substitution. Now there's also a special case of chain rule, where you are not making a function of x only, just to be u. You are not making it probably a trigonometric function. Let's say you have y equals sine 5x. This is sine x raised to power 5. Now in this case, this is where it becomes very tricky. Now you see this sine x. Remember, this can be written as sine x raised to power 5. Now what I'm going to do is that wherever I see sine x, I'll change it to u. So let u become sine x, because this already have a certain power. In our next video, we'll talk about functions of a function. That if this place was a very complex function, let's say x squared plus 3 plus 5, one stupid and very long function, we'll solve it this way and you'll see how you get the answer. So our du over dx, remember, when you differentiate sine, you are going to have cos. So we have cos x. Then our y becomes, remember we said u is sine x, becomes u raised to power 5. So our dy over du becomes 5 u raised to power 4. Now what do? We multiply these two functions together to get our dy over dx. So our dy dx becomes 5 times cos x times u raised to power 4. So we have 5 cos x u raised to power 4. Remember, we said u is sine x. So our u is sine x, we replace it and write sine x. So this will be our dy over dx. Shortcut again. Now remember that there's a power here, 5. First of all, you just take this, note this, that whenever there is a power and you are differentiating, the power must always come down. So the 5 comes down first of all to multiply. If there was 3 here, it will be 5 times 3. If there was 20 here, it would have been 5 times 20. So whatever is here, the 5 is multiplying it. We have 1. 5 times 1 is 5. Then now, subtract 1 from the power, so you have sine 4x. Now whenever you differentiate sine, you're going to have cos. That's why this cos x is here. So suppose we have y equals to 3 cos cube x. How are we going to get our y prime? Y prime is very straightforward and easy. First of all, the power comes down to multiply this. 3 times 3 is 9. So we are going to have 9. Then subtract 1 from the power. When you subtract 1 from the power, you are going to have cos square x. Then remember, anytime you differentiate cos, you get minus sine. So I'll put the minus here and put the sine x here. So this will be your answer. That's the best way of seeing this chain rule. It's very short and easy to approach. So that will be all for this video. In our next video, we may most likely solve more questions on chain rule, or we'll move over to product rule and quotient rule. So thanks for watching this video. Please do not forget to like and subscribe to our YouTube channel. Thanks.